Determine the equation of a line that is 7 units from the origin and it forms a 150-degree angle with the positive y-axis. Okay, let us begin. So first what we'll do, we'll try to understand the problem graphically. So here we have the xy coordinate plane. We have the line L which intersects the x-axis at point A in the positive direction and it intersects the y-axis in the positive direction at B. And here OC is the perpendicular distance of the line L from the origin, which is 7 units. Now it's given here that the line is forming an angle of 150 degree with the positive y-axis. Now we know the positive y-axis is in this particular direction, so this is the angle 150 degree that the line makes with the y-axis. Our goal will be to determine the equation of this line. So what we'll do here is use the normal form of a line. The normal form of a line is given by x times cosine of the angle alpha plus y times sine of the angle alpha, and this is going to be equals to the perpendicular distance p. But here alpha is the angle that the perpendicular line OC makes with the positive direction of the x-axis. So this is the alpha value that we need. We have the perpendicular value p, so that's equals to 7 units, but we do not have alpha. We are only given an angle 150 degree. But finding out alpha, that's a very simple task. So here we know that since this is 150 degree, the angle OBC, so the angle OBC, that is going to be equals to 180 degrees minus 150 degrees. That is going to give us 30 degree. That means we have this angle as 30 degree. So this is 30 degree, this angle is 90 degree. So what about this angle? So this angle must be equals to 60 degrees. So we know that angle BOC, so that is going to be 60 degrees. Now if angle BOC is 60 degree, then what is the value of angle COA? That's simply angle COA, which is the angle alpha. This is simply going to be 90 degree minus the angle BOC. So that angle is going to be 30 degrees. So we have obtained that alpha equals to 30 degree. So now that we have the value of alpha, let's substitute this into our normal form. We're going to get, so now we will have x times cosine of alpha is 30 degrees, added to y times sine of 30 degrees. This is going to be equals to 7, the perpendicular distance. So we have x multiplied to cosine of 30 degrees, which is square root of 3 over 2. Added to y times sine 30 degrees, that's 1/2, that's going to be equals to 7. Multiplying throughout with 2, we're going to get square root of 3 multiplied to x added to y equals to 14. So this is going to be the equation of the line. So square root of 3x plus y equals to 14 is the required equation. This is the required equation of the straight line.